sine x equals minus 1 for angles between 0 and 720. So the first thing we're going to do, in our calculator, x would then be sine to the minus 1 of negative 1. And that comes out in our calculator so we've got sine to the minus 1, negative 1. And it comes out as negative 90. See that? Ish. Yeah, there we go. It comes out as negative 90, yeah? X equals negative 90. So to diagram. So when we do this on our diagram, negative 90 is down here, yeah? So that's 270. So x equals 270, but we're not stopping at 360. So we also need to go around, all the way and what's 270 plus 360? 630. So x equals 270 degrees and 630 degrees because we had to check, like we didn't just stop at 360, we had to go around again. Question B. So 1, calculator. Oh, and for number 3, there wasn't anything else that needs doing. There was nothing extra special. X equals sine to the minus 1 of 0. Do that in your calculator. And you get x equals 0. If we draw that in our diagram, yeah, x equals 0 is fine, it's here. But we could have also gone around all the way and gotten 360 degrees. There's another one, because they said between 0 and 720. And I know we can go all the way around again. And get 720 degrees. So x equals 0 degrees and 360 degrees, and we could have also had 270 degrees. 720 degrees. Another way to do that question, and I actually think this other way is easier, but it only works when you've got boundary angles really, is we could have drawn diagrams of sine theta, like the graph. And this is the way I'm going to be pushing like later once we've had some more practice graphing. Whenever you're drawing a graph of sine theta, so this is the angle theta and this is y equals sine theta, it always starts off at 0. Let's just say we've got 0, that's better, 90, 180, 270, 360, 450, 540, 630, 720, yeah? Mostly because they told us to go up to 720. Well, I know theta is always 0 here. Wait, this isn't the only way it's 0. Oh, yes, it is, because this way's 180. God, I'm a bit of an idiot, frankly. Yeah. And this is 1 and this is minus 1. And you're going to learn, we go up to 90, down to 0, down to minus 1. I mean, up to 1, down to 0, down to minus 1, up to 0. And you're going to learn to smash this out really quickly, yeah? So it's actually 0 at all of these points. So if you put sine 180 in your calculator, that's 0. If you put sine 540 in your calculator, that's 0. If you put sine 720 in your calculator, that's 0. So I would recommend graphing it if possible. In this diagram, you could see that it came out as at -1 here and here. So yes, it was 270 and it was 360. That's really confusing. Please don't stress. I'm going to cover that more in person, if that makes sense. I'd rather do the graphing stuff with you guys in person. So, let's have a look at these ones. They're actually easier. I'm going to get rid of this question. You can hide down there. Okay. So we're finding an exact solution for these questions, if possible. So we've been told sine x equals -1/2. So chuck it in your calculator. X equals arcsine -1/2. So x comes out as -30. Number 2, draw your diagram. -30 is down here. So that's 330 degrees. But don't forget SATC. Sine is also going to be negative down here. Because, you know, we wanted -1/2. So we're down here and down here, and this angle is 180 plus 30, 210. So x equals 210 degrees and 330 degrees. But we've got the problem. It wanted it between -180 and +180. To get around this, every time you're not within the domain, you just add or subtract multiples of 360. 210 minus 360 equals -150 degrees. 330 minus 360 equals -30 degrees. So x equals -30 and x equals -150. So yeah, the reason we chose to do this was because we knew it had to be between 180 and 360. I mean, -180 and +180. You just add or subtract multiples of 180, of 360. To get within your chosen domain. Okay, so the next one, we've got tan x equals -3. So first step, x equals arctan, -3. So x equals -71.57 degrees. Let's draw this. So -71.57 is down here, which makes it 288.43 degrees. Okay, SATC, because we were after negative, we could also be here. So this one will be our negative 71.57. So what's 180 take 71.57? It's 108.43. So x equals 288.43 and 108.43. And double checking our domain, yeah, they're both there. So they're fine. Next example, let me get this one away. Next example's harder because we're now dealing with cosec and sec, yeah? So, we know cosec x equals minus 2, which means 1 on sine equals minus 2. And I'm just going to chuck it as minus 2 over 1, yeah? Which means sine x equals minus a half. I didn't need to chuck it as minus 2 over 1. I could have just done the minus out the front. So sine x equals negative a half. So we're actually solving this. So x equals arcsine negative a half. So in our calculator, it's negative 30 degrees. Let's draw it. It's down here, that's negative 30, so we know we're at 330 degrees. SATC, we know we're also down 30 this way, which makes it 210 degrees. Sorry, I really need to get these further down. Did not think this would take up this much room. Okay, so we know we're at x equals 210 degrees and 330 degrees, but we've been told between minus 180 and positive 180, so we've got, to get there, we're going to have to subtract 360. There's no point adding 360, that'll give us even bigger, so 210 take 360 is negative 150. 330 take 360 is negative 30. So we did that because of the domain. For B, we've got sec x equals 0.7. Now, don't forget sec 1 on cos. Equals 0.7. If you turn 0.7 into a decimal, into a fraction, that's 7/10, yeah? Using the S to D button in your calculator if you need, which means cos x equals 10 on 7. Now, you can put this in your calculator. Ten on 7, undefined. Because cos x can never be greater than 1. Same with sine. Like you're never going to get something bigger because something bigger, remember cos is adjacent over hypotenuse. Can the adjacent ever be bigger than the hypotenuse? No. Same with sine. But, you know, chuck it in your calculator gave us a math error straight away. So if you don't think you're going to remember that, just chuck it in your calculator.